let's solve some problems on the concepts what we have learned in graph theory, right. So, given a problem, find the number of vertices, number of edges, the degree of each vertex in a given undirected graph. Also identify all isolated and pendant vertices. So, what is number of vertices? Just count a 1, 2, 3, 4, 5. So, I will draw the line here. This is one graph, this is another graph, this is G1, this is G2. So, how many vertices are there here? It is 5. Number of edges you can count. Now, when you count number of edges, right, this is self loop, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right. So, there are 13 edges in the graph. Now, degree of each vertex, how do you find out degree of each vertex? We have already seen that when you find the degree of each vertex, how to find it out? It is the number of edges that particular vertex is incident on. So, A, we have to count this as 2, 3, 4, 5, 6. So, A degree is 6. For B, 1, 2, 3, 4, 5, 6, 6. Then 1, 2, 3, this is 3. For D, it is 1, 2, 3, 4, 5. And for C, it is 1, 2, 3, 4, this is 2. So, total 6. So, this is the degree of each vertex of a undirected graph. In the same way, what are the isolated and pendant vertices? What is called isolated vertex? Isolated vertex means a vertex which is not incident on any or I would say if the degree is 0, that particular vertex is called isolated vertex, and if the degree is 1, then that kind of a vertex is called pendant vertex. Isolated means degree 0. So, in graph G2, if you see, we have two isolated vertices, D and F, because their degree is 0. Pendant, we do not have any pendant here. Pendant means any vertex whose degree is 1 is called pendant vertex. So, we can expect some kind of problems like this. Then identify the in degree and out degree of for the given multigraph. In degree and out degree. Since it is directed, we will have to find out in degree of A, out degree of A. Let us find out for this and see what is in degree. In degree means number of edges coming towards A. So, 1, 2, 3, 4, 5, 6 are coming towards A. So, this is in degree. What about out degree? Number of vertices, number of edges going away from A. So, this is going away, you see 1, that is it. So, it is 1. Okay. So, you can even count like this 1, 2, 3, 4, 5, 6, 7. So, this sum is 7, right. So, this way you have to find out in degree and out degree. What is in degree and out degree for E? 0 and 0. Okay. Let us see the in degree for D. In degree for D and out degree for D. So, you have to give the in degree and out degree for all the vertices. For D, how many are in degree? See, this is coming towards in, all these 3 are towards coming D. So, in degree is 4, because all these 4 are coming towards it. What is out degree? Number of edges going towards, going away from D. So, these 2 are going towards A, means going away from D. So, this is 2. So, this way you have to find out in degree and out degree of given vertices. Next, draw all subgraphs of this graph. What is subgraph? Subgraph means from a given, if a graph G is a combination of V and E. Okay, if you form a new graph, G dash, such that it has V dash and E dash, where V dash is subset of V and E dash is subset of E. Okay, it means from a given graph G, if I can remove some set of vertices or some set of, again if I remove vertices, edges are removed. If I remove some set of vertices and form graph, those graphs are called subgraphs. Maybe with example we can understand this. See, this is a graph. What could be one subgraph? One subgraph could be this A, B and C. Why? I removed the vertex D. This is one subgraph. Another subgraph could be like this, A, B and D. This is one subgraph. Why? We have removed the vertex C here. We have removed C. Like this, how many subgraphs are possible? That I am trying to find it out. So, if I remove now B, what will happen here? What will be the graph status? It will become A, C and D. I have removed here B. But can I remove A? If I remove A, a whole graph will become disconnected. But that graph should be connected. That graph should be connected. If I remove A, in this case, if I remove A, what will happen? These three will be deleted. So the graph will become simply like this: B, D, and C, which are not having a single edge. That cannot be a subgraph. Okay, subgraph means it should be connected graph. There should be at least one edge. There should be at least one edge. So these three are subgraphs. Then if I remove both C and D, if I remove both C and D, still I can get one subgraph like this: A and B. This is one subgraph. If I remove C and B, still I can get one more graph like this: A and D is a subgraph. Okay, that way you can remove some set of vertices or some number of vertices and form the subgraphs. So all these are the subgraphs of this graph. Okay, next problem is degree sequence. What is this concept of degree sequence? Right, if you have a graph with you, okay, for that graph you know how to find out the degree of each vertex. Okay, given a graph, find out degree of each all the vertices. After finding out degree of all the vertices, if you write the degrees of the vertices in descending order, if you write the degrees of all the vertices in descending order, that sequence is called degree sequence. See, non-increasing order, decreasing order. Okay, let's take an example. Let us find out degree of this graph. For A, degree is 3, for B it is 1, for D it is 1, C it is 1. So the degree sequence of this graph G will be 3, 1, 1 and 1. This is degree sequence, writing them in descending order. Okay, let's take another few graphs and find out degree sequence. Maybe I'll take, let's find out degree sequence for this graph K23. What is this? 1, 2, 3. What is this? 1, 2, 3. What is this? 1, 2. This is 2. This is 2. If I direct the degree sequence of this, it becomes 3, 3. Then comes 2, 2. You have to write in decreasing order of that degrees. That is called a degree sequence. So what is the problem here with the degree sequence? Right, the problem with the degree sequence is given a degree sequence. Okay, given a degree sequence, find out whether we can draw a graph or not. Given a degree sequence, find out whether we can draw a graph with those degree sequences. Okay, let's solve. So before that, the sequence d1, d2, dn is called graphic if the degree sequence of a simple graph. Okay, so this is called graphic degree sequence if you can form a graph. Let's take example A. What does it says here? See, it is giving the 5, 4, 3, 2, 1, 0. So I will take this space here. The degree sequence given is 5, 4, 3, 2, 1, 0. It means these are the degrees of the vertices of a graph. How many vertices are there? 1, 2, 3, 4, 5, 6. Let me draw 6 vertices here like this. Now, it can be anything. First vertex is having 5 degree. Okay, let me connect this 1, 2, 3, 4 and 5. Next vertex is having 4 degree. So means 1, 2, 3, 4. Now this has become 5, this has become 4. Next is having 3. Maybe if from here if I connect this to this, from here if I connect this to this, it becomes 3. But you see, once I connect this like this, once I connect it like this, no, I am having, I will not connect this. I will connect these two. So this becomes 3 now. This becomes 3. Now I have another sequence 2. Do I have? Yeah, I have a 2. Then 1. No, there is no vertex with degree 1. There is no vertex with degree 1. So this is not satisfying. So given this degree sequence, I am unable to draw a graph. Okay, let's take another example. Let's take this, maybe let's take D, 3, 3, 3, 2, 2, 2. 3, 3, the degree sequence given is 3, 3, 3, 2, 2, 2. How many vertices are there? 6 vertices. Let's take, let's take 6 vertices in a rhombus shape. Now 3 means 1, 2, let me connect this like this, 3. Next, I got 1, 3 satisfied. Next, second one is 3. Maybe if I connect these two, this is forming 3. Then another one with 3. Another one 3 means if I connect these two, this has become 2. And then I will put one line like this. So this has become 3 now. This has become 3. Now with vertex 2, yes, I have 2 here. With vertex 2, I have 2 here. With vertex 2, from where can I connect this? Can I connect this to anything? No. I am unable to draw a graph here, right? With this 2, I am unable to draw a graph, because if I connect, this is 1, but if I connect this to this is becoming 3. If I connect this to this, it is becoming 4. If I connect this, it is becoming 4. It means I cannot draw a graph with this degree sequence. Okay, so you see this 2, 2, 2, 2, 2, 2. Third one. So the degree sequence given is 2, 2, 2, 2, 2, 2. Can we draw a graph like this? Again, let me draw the vertices like this and check 2 like this, 1 like this. You connect, it will form 2, 2, 2. See, the degree of this is 2, it is 2, the degree of this is 2, the degree of this is 2, it is also 2, this also 2. We got a graph, right? So the problem here is, given a degree sequence, find out whether we can draw a graph with that sequence or not. And it should be connected. It should be connected, because it is a simple graph. It should be connected graph. Okay, see this example. Can I draw a graph 4, 3, 3, 2, 2? A degree sequence is given. Find out whether we can draw a graph with this sequence or not. So 4, 3, 3, 2, 2. 4, 3, 3, 2, 2. It is clear that there are 5 vertices. If you count number of degrees given, it means there are 5 vertices. So 1, 2, 3, 4 and 5. 4 means definitely I have to connect like this. Sorry. 4 means definitely I have to connect like this. Then this becomes 4. Next 3. Let me connect to this and let me connect to this. So this becomes 3. Next another 3. So if I connect this to this, if I connect this to this becomes 3. Then another 2. Yes, there is a 2. There is a 2. Yes, we can draw a graph. We are able to draw a graph. It is possible, right? So given a degree sequence, identify whether we can draw a graph is the problem. So you can solve these remaining exercises and find out whether we can draw a graph or not. Okay. Next, graph union. Again, this is a simple concept. Union of 2 graphs. If there are 2 graphs G1 and G2, okay, if there is at least, see, it's a simple graph with vertex set V1 union V2 and edge set E1 U2, E1 union E2. If you can merge them, then we say the union of G1 G2. See, this graph is there here, A, B, C, D, E. How can I merge them? You just draw the vertices. What vertices you have? A, B, C, D, E, F. A, B, C, D, E, F you have. Now draw G1 as it is. Draw the G1 graph as it is. So 1, then 2, then this. I am trying to draw it like this. Now what are the pending vertices? From C, A, B, C, D, E, F. You have to union them. G1 part is over. Now you see, A to B exists here, satisfied. B to C, satisfied. B to D, I have to draw this line. Then B to F, I have to draw this line. Then C to F, I have to draw this line. So this becomes the union graph. So combining 2 different graphs, first you mark all the vertices, draw the graph G1, and also find out whether all the edges of G2 are also present in G1 or not. That will give you the graph union. Okay, so this is the result what we found out, G1 union G2. Okay, so these are again few kind of problems which we can face in graph theory. Next we will see how to represent graphs. Okay, how do we represent graphs? We will see that in next video. Thank you.